Thanks, Irish. So can you see that okay? Yeah.
Yes, that's perfect.
Cool. Yeah. So yeah. So this talk today, I'm going to start off by giving some background. So an introduction into PWN2OWN. I mean, I'm sure you're all familiar with what PWN2OWN is, but I'm just going to cover that. Go through some of the history, some of my history of participating at PWN2OWN and the teams which I was part of at the time. And then also like PWN2OWN events, the kind of experiences and learnings, so me, basically I've been doing vulnerability research for 15 years plus now. I've looked into quite a few different areas across most operating systems, embedded systems, cloud, and so on. But the talk is really about teamwork and how together we've kind of done these competitions. So the PWN2OWN itself, if you're not familiar, then there's now multiple different events. It started off where there was only one, there was only PWN2OWN desktop, but then they introduced the mobile, ICS and SCADA, and then there's a new event in January starting, which is going to be purely automotive, focusing on cars. The goal of the competition is to compromise some targets, the list of targets which ZDI provide. There's prizes based on the expected level of difficulty of the target. So it's how like ZDI perceive the level of difficulty of that, of compromise, getting remote code execution on that target. ZDI purchasing the vulnerabilities and providing them to the vendors. So they're not, they're giving them directly to the vendors and being ethical with the vulns. The rules are quite, there's some common rules across the different competition, across the different types of PWN2OWN competitions. So things like you're not allowed any user interaction, so you can't say like fish a user. The initial, there's a draw for the contestant order, and the order which you participate in next so basically each contestant can only attempt one chain of bugs per category, and then there's 5-minute attempts per, like, over that 20 minutes. The vulnerabilities themselves, they need to be unique, so you have to find ODAs. They can't be issues which the vendor knows about, and if it's a collision, or if it's a bug which is already known about, then it's a problem. So the order of the which you participate in the competition actually matters. It's a partial win if, say, certain bugs in your chain are already known. So if you have a collision with another participant, or ZDI already know about the bug, then it's not a total write-off. You get a share of the money. And then there's specific rules per category as well. So things like if you're doing the desktop competition, you normally have to break outside of the sandbox. You normally have to use multiple different vulnerabilities to break outside of the sandbox. But whereas the IoT, it's slightly different, and ICS is different. And then finally, you're not allowed to disclose any of the vulnerabilities until they're fixed. So myself, I've competed now in 4 different events. In 2018, we went after this mobile macOS Safari, which we used a vulnerability in SVG to start off with in the renderer of Safari, and then we used an IPC vulnerability to break outside of the sandbox and get code execution there. And then in 2018, we also did a mobile PWN2OWN, which was a logic bug chain against Huawei devices, and it was mainly using kind of like really specific Android features of the IPC subsystems. Then recently with NCC, I've done PWN2OWN Austin, so focusing on Western Digital NAS, Lexmark printers, Netgear routers, and more kind of IoT-based type systems. And then last year we did PWN2OWN Toronto with compromising routers, the Soho smash up, which is what I'm going to talk about today. And yeah, so one thing I haven't really talked about in the past is my PWN2OWN fails as well. Like it hasn't always been successful. Normally when we got things together for the competition and we were at the competition, we were successful, but there were times when this just didn't really happen. So in 2022, we were trying to do the PWN2OWN desktop. We were going for Ubuntu in the local privilege escalation category. But then our bugs got killed by, Project Zero and somebody else. And then we didn't actually get to the competition. We didn't actually manage to get the exploits written in time for that. We had time, and we had times when bugs were found before the competition as well. So in 2019, I was researching Samsung's Shannon baseband. And I was looking for over-the-air code execution vulnerabilities in the baseband, but that got fixed as well before the competition, which was kind of annoying, but it's just the way things are. And same with in 2018, our first bug, we had a vulnerability in Safari in WASM in the WebAssembly code, and Natalie from Project Zero also reported that and killed that bug before the competition. So, but we were lucky because we had all the tools developed for fuzzing and triaging and so on, and we found a bug quickly in time. And then there were just times where we just didn't find anything. Like there are easier targets than others, and there's ones where, I mean, generally the security posture is quite good, and just in the time we just didn't find any issues. So and then finally with the IoT devices, because the security posture is quite low compared to some of the some other more higher end things, we ended up with a lot of collisions. Yeah. So some kind of general experiences from the competition. When I started doing these, I was doing consultancy, and it's quite hard to do PWN2OWN when you're doing consultancy. Like there isn't really that much time, and PWN2OWN takes a lot of time to work on. There was a lot of distractions just about general kind of business going on, but the company was pretty supportive of the competition. They wanted people to participate, and they supported me as best they could, and others as well. They had success with Chrome, Samsung Mobile, and Amazon Mobile. So there was definitely a lot of people within the business who were wanting to do PWN2OWN and were quite motivated, and that built up that kind of competition feeling within the business. But it was a lot less structured as well. It was kind of like, go away, find some bugs. If somebody finds a good bug, then we'll maybe write an exploit for it. There wasn't really much planning to it. Whereas like now, we started structuring things better and making better usage of what people's like primary skills are. My team is EDG, which I work on at the moment. We're 100% dedicated R&D, research and development team. So we're not having the distractions from consultancy and the time demands on that. But we've also got things like hardware security team here as well, who just specialize in just doing hardware security. So if we need things like I don't know, dumping firmware or hardware-based attacks to gain access to the device first before we can do our looking for bugs, then we've got those people available. And we've also got like better shared knowledge repositories, because over the time of doing PWN2OWN, then you build up a knowledge of that target and you understand where the weaknesses are. And that just generally gives you like a lot better, like good understanding of the target and just general like vulnerability research experience built up over that time. And then the final thing as well, which wasn't obvious to me before I started competing as well, was like the device procurement, like buying the actual devices for things like IoT kind of matters, because you can like, do you make the decision to look for bugs like statically and just look at like analyze firmware, do reversing if you can get the firmwares beforehand, or do you just buy all the devices and then try to look for vulnerabilities across like all the devices which you've got? That obviously costs a lot, quite a bit of money if you take that approach, and you might not find things. So yeah. So in general, my feelings of this of PWN2OWN is that they're generally easier targets in the mobile and IoT sector. Like the embedded systems are a lot easier than, say, like desktops, which have got multiple mitigations and have been like hardened to hell. It seems like the ICS event is the vulnerabilities found in ICS are not super complex either, and might be a good place to start, but I've never looked at that one. You can see this by the prize money. I think like ZDI, like I agree with this. This is kind of the way they've priced the targets. You see not many people targeting the Pixel or the iPhone these days because the amount of effort which it requires to develop a full chain for the iPhone is pretty crazy now and worth significant amounts of money. You can so yeah, just generally, and also you can do the IoT and mobile category as well without any real hardware skills. Like we had a hardware team available, but a lot of the time we didn't really need to use them. We could just kind of just download firmwares and start reversing it without actually having to like dump chips and dump eMMCs and all that kind of stuff. The desktop requires multiple vulnerabilities chained together. So you'd require like a browser renderer plus a sandbox escape, and then you'd also require mitigation bypasses as well. So you're not just going to be able to, you're unlikely to be able to complete the desktop categories now with just one vulnerability, or it's likely to require multiple ones chained together. And browser vulnerability research as well, it's quite like a specialist area. There's people who are doing browser vulnerability research full-time who are just concentrating on that and nothing else. So it's the learning curve is quite steep now. I've never done the ICS category, but the vulnerabilities look quite trivial. So maybe the barrier there is just getting access to the hardware and the software which is used in the ICS categories. So target choice, then what do you think about if you're thinking about PWN2OWN, then how do you decide on what targets to go for? So the perceived level of difficulty, like what are ZDI offering for the target? And do you agree, like, do you think that makes sense for the level of difficulty? Are people wrong in what they assume? Like, are people overestimating the difficulty of a target? That's very hard to say without like looking at it first, but you kind of gain an understanding where people might be like, oh, this is a bit overrated. Collisions, if you're finding shallow bugs, then it's likely that other people are going to find them too. So it's a trade-off whether you want to go to the competition with shallow bugs, or whether you spend more time looking for more in-depth issues which less people would, which people might not find. The target knowledge, like, do you already understand the target in depth? Like, do you already understand the code base and put possible vulnerable areas? Like, if you've got that knowledge already, it's like a really big help. And there's certain people who are good at like finding like a specific class of vulnerability. So if you've been, say, looking at Android security a lot, you've been focused on Android IPC, then you might be an expert in Android IPC, and you can find bugs in that which other people would not find or wouldn't find easy. So that's like maybe a good one to look at. Debug capability is like a huge thing, because like if you don't have any introspection capability on the platform, like if you can't root it first and you can't get access to the firmware, then you're kind of limited to just like black box testing. There's not really like, so being able to like jailbreak the platform first or get a shell on it first is really useful. So for the embedded, you kind of need to think about that. Like, do you have any vulnerabilities available, like which could enable you root access to the platforms? Because if you've already got vulns which can give you access on older versions of the devices, then this is like super useful. And then finally, like tooling capability, like do you have fuzzes for this, or do you have like specific code review tools to find like different classes of bugs? Then that can give you an edge as well. So the methodology which we used in 2021, this was just my team, and we'd start off by looking at like static, like firmware analysis, unpacking, and then at the same time somebody else would do some like dynamic analysis, like mapping out the attack surface with nmap, like understanding the ports, what network services were listening, and then we kind of like feed it all together. So one of us would maybe like work out how to decrypt the firmware or dump the firmware, and then once we'd got that, we'd be able to and then we'd have another person looking at, like, say, the hardware interfaces like UART or JTAG and things like that. And we'd basically all put it all together to actually gain access to the device and to start to basically seed our vulnerability research. And I've got another presentation about that, going in more depth on that. So the kind of process which we were following for embedded was to start off with background research. So understanding what previous vulnerabilities were present on the platform, what CVEs there were in the past, and what people had published about that platform. And some targets, there was just no real information online, whereas like other teams have documented their research over the years, and they give kind of a really good understanding of the platform. Then we gain device visibility, so getting the firmwares, getting the debug capability, so we can actually analyze the services and so on. Mapping out the attack surface, understanding what's there from a network perspective. Then moving on to the actual like bug hunting phase, reverse engineering, code reviews and fuzzing, feeding that back into like tooling and automation. And then once we've found an issue and we've written a POC for it, then it takes a while to get the proof of concepts to a level which is good enough for PWN2OWN. So we have to go through like quite a bit of testing, packaging things up, and actually testing whether it's going to work. Because with PWN2OWN, if you're participating remotely as well, if you're giving it to ZDI, then they need to be able to run the exploits and be able to without having any problems. So there needs to be like quite a bit of testing going on. And testing like is super important, because like we've had exploits which would work in one environment, and then we ran them in ZDI's environment in the competition and just didn't work, and we're like, okay, that's pretty weird. But we've seen other people make mistakes in like fail the competition because they've made they've hard coded something in their exploit, or they've packaged it up wrong. They've used like a Docker container, but they can't modify it or something like that. You need to make sure your exploit is easily updatable as well, because firmware updates can come out just before the competition. You need, like, offsets can change. You need to document this so it can be done under pressure. So for PWN2OWN, this wasn't too, we didn't do it like too automated, but then for the Linux kernel, we started automating this, and that was what me and Cedric talked about at OffensiveCon this year, about building more reliable exploits and the processes around those. And then finally, we did creating usage guides to ensure that exploits are executed in the correct way. Yeah, I've said about that. If you're doing it remotely, then ZDI are running them. Basically, it's just proper software development for exploits. So in summary, for learnings, then look, instinct, and being stubborn is important. With any vulnerability research, there is an element of luck. If you're looking in the right places, you might stumble across vulnerabilities straight away. But being stubborn enough to keep going when you don't find bugs and keep looking is important. The teamwork and team size does matter. Like, it is a lot harder if you're participating on your own. If you have other people to work with, you can keep each other motivated and share knowledge. the problem with and in the past, there's been some like pretty huge teams out there as well, which have just been focusing on things which kind of gives a bit of an advantage. But you need like laser focus, you need the grind, you need to be able to like put the time in to find the bugs. Building the knowledge and building the knowledge bases and tools is important, like reusable tools across different targets or across the multiple different years which you're participating in the competition. There's always a question in vulnerability research between like going deep and going wide. Like, do you go deep in one area like to start off with, or do you start with like a more wider approach, like understand all the different possible attack surfaces and then work out where you want to start going deeper into the different areas? So I think it's important to work out when you're going to like take the different approaches. Attacking the problem from different angles like really helps. Like if you've got multiple people working on different areas, then you're more likely to find bugs and exploitable vulns. The more attack surface you've got, obviously the more chance of finding vulns you've got. So if you just limit yourself to one target, you just might not get there because you might not find anything useful. But you also run into this like fragmentation of effort problem as well, where if you fragment effort too much, then you might not go deep enough. So yeah, and embedded is probably a good place to start if you're looking to just get into these competitions, because there are easier targets in the embedded one right now. So that was it from the kind of high level like PWN2OWN learnings and experience section. I'm now going to go into like some of the technical vulnerabilities and exploits. So I'll start off with the Soho router chain, what we use to compromise ubiquity routers, and then from the ubiquity router compromise the Lexmark printer. And then if people are still interested and want to stick around, I'll talk about Lexmark, a Lexmark vulnerability as well, and what we used the previous year. So the Soho smash up, this was introduced last year, and the aim of it was you choose a device on the initial stage list. So you would choose a router or something, you choose a router from this list, gets remote code execution on the router via the WAN interface, and then you would use that to pivot to compromising a device on the final stage. And the final stage was it was like speakers, printers, and NASs and so on in the final stage. So from an infrastructure diagram perspective, you'd have your attacker PC or desktop trying to attack something over the WAN, trying to attack a router over the WAN, compromising the router. Then once you've got code execution on the router, using that to attack something on the LAN interface. And in our case, we attacked a printer from there and got code execution on the printer. So the ubiquity vulnerability which we found, it was a vulnerability within the DHCP v6 option parsing code. In this, some functionality called prefix delegation. So prefix delegation itself, I'd not heard of this before I'd started doing this research, but it's something a bit like NAT, but for IPv6 networks. And it allows a router to be assigned a specific range of public IP addresses. And then these public IP addresses can be delegated to other devices on the LAN interfaces for to share these public IP addresses and so on out to the different devices on the LAN interface. It's fairly niche, and I don't think there's that many people in the world which are running it. But from Googling around at the time, there were definitely people who had their ubiquity routers configured to do DHCP v6 prefix delegation. So it was a valid attack vector. The vulnerability, it was in the IPv6 option DNS parsing. So the way this works with DHCP, options are passed from the server side to the client. And that's kind of the way which the server can propagate information. And one of these things is the domain search list. So the server can provide a domain search list to clients. So the domain search list, it basically the code which is used to handle this, then it's DHCP6 get domain function. This basically loops over the different options for this, and it calls DNS decode on the DNS names which it receives. So this is essentially attacker controlled data, the DNS names which are passed. So you can't, I don't know if you might be able to read that, but in the DNS decode function, there's a bit of sanitization happening for characters, but it doesn't prevent certain malicious characters. So we were looking at this and we were thinking, okay, well, we could get, say, a curly brace through double quotes, semicolon, dot, and things like that. That's quite interesting. Like if we could get those injected into somewhere, then we may be able to actually exploit this. So where does it go? Basically, it gets assigned to this new domain name variable, and then the new domain, and then this is basically constructs an environmental variable called new domain name, and then this is exposed to some Perl scripts. So we dived into the Perl scripts. So in the Perl scripts, there's a script called UBNT DHCP6C script. So the DHCP6 client will take this and it will execute this prefix delegation response Perl script. And the prefix delegation response Perl script, that takes the new domain name, which we control. And it doesn't do any sanitization really of this. It just regexes out. It has a string, but doesn't do any checking on this, any further checking. Well, okay, where does this go? So looking more at the Perl scripts, we can see it loops over each of the prefix delegation options within the config file. Then it loops over the different interfaces. And it has separate handling for the different services which are supported under prefix delegation. So in prefix delegation, you have Slack, which is some kind of like auto configuration for IPv6, but then you have one called DHCP6 v6 stateless and DHCP v6 stateful. So if prefix delegation is configured on the router, then we basically end up here, and it's passing our domain to this, which is attacker control again, to this setup DHCP v6 stateless function. Then if we look at the setup DHCP v6 stateless function, we can see that it takes the domain and basically just does string concatenation when constructing the string. So there's no sanitization really occurring here, and it's just constructing the string. So we've got config injection because this is creating a configuration file which is used. So what can we do? So so our malicious server can now provide this option. It can do things like double quotes, script / just as an example, inject that in, but that's not actually that useful. So how do we actually exploit this? Well, firstly, we need to, our injected string is part of the string, so it's getting concatenated together. So firstly, we need to close off the string. Then we can start our injection with a semicolon, but Perl's adding its own semicolon as well. So you basically need to end up with something like this, like double quotes, semicolon, the malicious thing you want executed, and then a hash to comment out the rest of the config file. But we were looking in the config file for DHCP for the binary, and in this specific config file, like DSL and the kind of language which it was using, we found an execute command as well. We're like, oh, that's pretty cool. We can just like inject in an execute into the config. But there was a problem with this. We couldn't do a connect back. I mean, so we couldn't do we couldn't do a bind shell because the firewall was pretty restrictive. We didn't have we had payload restrictions, so we could only inject in certain lengths, like a certain number of characters. So we couldn't say like drop the firewall because we didn't have enough characters to do that. So what we managed to do was to do like a reverse connect back using the link local. Yeah, so the payload, it was limited to 63 bytes, and IPv6 addresses are quite long. So basically, to exploit it, we do double quotes, semicolon, execute, and then netcat, because netcat's luckily already installed on the Ubiquiti switch, which connects back to our attacker over link local on port 1, because that's all we had. We had to use a single digit port because that's all we had the size for, and executes the shell. So this is what it looks like in the switch configuration, in the DHCPv6 switch configuration after the injection has occurred. And as you can see, like, this is actually syntactically correct, and the config will be parsed correctly. So that was our stage 1. That was getting us code execution on the Ubiquiti device, and we now have a shell on there. We now need to implement the stage 2, because we're going to attack something from the Ubiquiti device over the LAN interface. We actually had a few vulnerabilities or exploits available at that point. We had a Canon printer exploit, and we also had multiple Lexmark exploits. So we had the choice which ones we were going to go for there. And we made some choices around like what we thought would be less likely to collide and most reliable for the competition. The Ubiquiti as well, it didn't have a Python interpreter, and we've written our exploits mainly in Python. And so we had some options there to basically, we could either statically drop a Python interpreter on the Ubiquiti device, and that way just run our second stage exploit code in Python. We could re-implement our exploits in C, but that would have been a pretty tricky task. We were exploiting memory corruption bugs in our second stage, and it would have just taken a lot more time to re-implement in C. Or we could proxy things through stage 1. In the end, we just decided to drop the Python interpreter because that was quite simple to build a Python interpreter for MIPS. Yeah, so this is the exploit running. This is a demo. So you can basically see, we called it Rainbow 6. This is basically listening on our interface that's the IP address to connect back to when it makes the connect back. And then you can see the DHCP6 v6 server starting. It's waiting for a connection. Then we boot the Ubiquiti router is booted. It basically, the exploit is triggered, the injection happens, we receive a shell from the Ubiquiti device to connect back. Then we upload our stage 2. As you can see, the stage 2 zip is being pushed to the device. Then after we've got our shell, we modify the firewall, we start telnet running, and then we just netcat in to get a regular telnet shell on it, and we've got root on the Ubiquiti device. So that's our stage 1. So now we're on the device. Our stage 2 has already been uploaded, and we can then as I said, we coded it in Python, and we've dropped out a Python interpreter on here as well. So we run our stage 2. This is against the printer, And then this is exploiting a PostScript vulnerability within the PostScript interpreter, which I'm not going to be talking about today, but I'll get onto that in a second. And this is getting code execution through in PageMaker, which is the PostScript interpreter on Lexmark printers. And as you can see, we're cat in the bell file, and you can see we've got access to the printer as well. So that was what we did for this Soho chain at PWN. So I guess the question now is, do you want me to go onto the more contents? Like I can talk about Lexmark printer vulnerability from last year, or are you all bored and want to go home? So, yeah. Should I continue, Ash?
Yeah. So I think many people are interested to
Okay.
to be continued. It's perfect. Thank you.
Cool. Okay. So at PWN 2022, we had multiple different vulnerabilities within the PostScript interpreter. I can't disclose I don't want to disclose the PostScript vulnerabilities right now, because Aaron, my colleague, is speaking at Hack in the Box in 2 weeks about PostScript, and that's basically like a talk in itself. It's going to be really in-depth deep dive into the PostScript interpreter, how PostScript works, and there's quite a bit of like PostScript internals which need to go on. So I'm going to talk about the vulnerability which we used in 2021 instead. This is based on our Hexacon talk, which you may have seen, but hopefully not. So basically the vulnerability in 2021, it was in a binary called Hydra. Hydra was a network listening service which handled print-related functionality. So on printers, you have languages like the printer job language, PGL, and printer control language. They used to perform things like laying out of the pages and instructing the printer, but they're both handled by like interpreters, like the specific program. They're like programming languages essentially. And the huge binary, and it's also a huge binary with lots of functionality within it as well. And it's network accessible, so it's exploitable over the network, so good for PWN. So this is what PGL looks like if you've never seen it before. This is actually what gets sent over the wire to printers if you've got, like if they're using PGL to do some type of printing. So we reverse engineered this, and we looked for the different handlers for functionality. And we came across a command handler called LDL welcome screen, which was something which Lexmark had implemented themselves. This wasn't part of the standardized PGL specification. So this was an interesting one because it was like something which Lexmark had added. So we looked at the code for this, reversed the code for this, and you can basically see that it's taking the arguments from PGL as like a file, and then it's parsing the arguments, this file parameter, and it's passing it to PGL handle LDL welcome screen internal. So this is interesting. It's like, okay, what's it doing with this file? So we reversed this, and we could see we could control the file name entirely. We're like, oh, that's pretty cool. Like maybe we've got an arbitrary file, right? So we looked into this, and we looked at PGL LDL welcome internal to see what that does. So this function, it basically opens a file descriptor or opens a file, calls this inner function, closes the file descriptor, and then removes the file. The removal of the file is pretty annoying because like, okay, why did it just create a file and then just remove it straight away afterwards? But but we're okay, like we need to confirm this file right. And so to do this, we found a CGI script which would allow reading of files. It would normally read this varfs shared event log logs and then a debug log, but normally that wouldn't be there. but we used our arbitrary file right to write that file. And you can see we just wrote those AAAs and we're like, okay, this works. And at this point, we didn't have a shell on the printer. Like we didn't have an interactive shell, so we didn't know if our file was getting created. We had to do this purely from like a black box perspective. And it was good because it was a logic bug. It wasn't a memory corruption. It wasn't something we needed a debugger for, but it gave us an arbitrary file right. But to actually exploit the arbitrary file right wasn't as straightforward as it could have been, because as I said, the file was getting removed straight away afterwards. It would only like exist for like very, very like briefly. But what we could do is we reversed the handling of the data reading part of writing the data in the file. And because the file was, because the data of a PGL was read in block sizes, we could basically send like before the amount of data which it expects, and we could cause the function to block. And because we were blocking the function we could do that without completing the data, and also not sending the PGLN data handler as well, which basically ends the data stream. Then the function would block and our file would stay there. So that basically gave us an arbitrary file right, which was pretty cool. But we had another problem. We're like, okay, what do we do now? We've got an arbitrary file there. How do we get code execution? Because for PWN2OWN, you need full code execution. And the file system, it was mounted as read-only. So you couldn't create files on certain parts of the file system. But there was this overlay file system in place. It was overlay file system in Linux. But we couldn't overwrite existing files. Like to get code execution normally, if you could overwrite an existing file, and then if that file is used, then it would be like a good way of doing it. But we couldn't do that. So we found this directory which was called etc libreports events.d. And what this was this was mounted in the overlay file system, which would basically allow us writable access to here as long as there wasn't an existing file in place. So we had a look at how this works, and we're reading the man pages for this, and it was called this functionality called ABRT, and like it's a way of implementing crash handlers. So you can implement like a core dump handler, and then if a core dump gets created, then we'd basically like have this file being triggered. So you can write like event hooks for say if a core dump file is handled, which was pretty cool. So we could basically write a config file which would get put in this directory, which would get picked up by the daemon and trigger an action which would give us code execution. But then we had another problem as well. It's like, how do we get a core dump file created? Like we need to do this remotely. We need to do this over the network. Okay, we just need to crash service. So how do we crash service? Like we started fuzzing the HTTP stack just to see what would happen if we could get any like simple, like, I don't know, like a null pointer dereference or something, just to trigger a core dump. And we found one. We actually found a invalid pointer getting passed to free in with awk. So there's a script which was running on the device which would monitor the log files, and it would apply a regex, and it would try to look for certain patterns within the log file. But one problem was that the log file gets rotated every so often, and if we manage to trigger this, if we manage to trigger a log rotation and then this awk expression when there's no actual log file there, which is like not normal behavior, then it would basically trigger this invalid pointer exception and cause the core dump to get created. So what we did to do that, we basically we spammed the HTTP service with GET requests, in order to fill the log files, cause a rotation, and because two instances of the same of this script basically does the act on the same file name, we kind of race it, and we have one which removes the log file, and the second one tries to act on it before it's been recreated again, which triggers this. And so finally, this is what the full chain of this one looked like. We had our first thread writing to the config file, using the PGL vulnerability. Then we had a second thread trying to trigger the Gawk crash by using and getting the abort config to be triggered. And then finally, we would have once that's triggered, we'd start a shell, and we'd connect back, and we'd obtain a shell on this. So here's a demo of the PGL bug as well. So this is just us exploiting the printer. You can see it's creating the file, trying to create the file through the PGL vulnerability. It's waiting for the file to be created and blocking in the thread. Then we start our separate crash thread, which triggers the crash handler. The crash handler basically triggers, drops, spawns SSH, and then we can SSH in and get a shell on the device. So it's pretty cool. We used another logic bug there as well. And this was our first time gaining a shell on Lexmark printers. And this was really useful for future research, which we were doing the year after, where we needed a debugger on the printer to exploit our memory corruption bugs. So in conclusion, I hope that this talk was valuable. I hope that some of the experiences the high-level experiences which I gave were useful. And if you're thinking about doing the competition, it's things which would be good to think about. And I went through some technical bugs. These are not the most technical bugs which I've ever found in my life, but it gives like an overview of what type of bugs exist in embedded systems, and maybe like some easier ones for people to find, compared to really, really in-depth bugs, and hopefully it motivates people as well. So yeah, are there any questions? Thank you.
Okay, thank you very much, Alex. So first of all, I should apologize everyone, because there was kind of some spams around the stream. I should apologize that. But so for this, I disabled the chat as well as so people want to unmute itself. So the thing is, if you have questions now, you can probably unmute yourself and start speak up. And I just enabled everything. So if everyone wants to ask questions from Alex, it's open. Yeah.
I've got a question. I can be heard.
Yeah.
Yeah, so hi Alex, thank you for the great talk. I'm actually looking at PageMaker in a minute on Lexmark and taking it apart. So I know that the Hack the Box talk is coming up in a couple of weeks. Will the slides be published after the talk for those that can't watch the talk or aren't in Thailand at the time?
Yeah, I think so. I think Aaron will publish I don't think he's got any plans of speaking at another conference. I think he will publish, yeah, straight after. Yeah.
Brilliant. I suppose next question. If I can
No worries. Good luck with that.
Any tips for people looking to reverse PageMaker, and how did you find it? Because I'm looking through it and it's a struggle.
Yeah, I think you really need to watch Aaron's talk, because he was saying on Twitter that you need to kind of understand how the interpreter works, and how PostScript like language parsing works. It's not the easiest target to reverse, and we developed scripts for doing it, like automating a lot of the tasks and understanding how to reverse it. But yeah, I'll leave that for Aaron's talk. Yeah.
Thank you.
Thank you.
Hi, Alex. Can I ask a question?
Yeah, go for it.
Yep. Thank you very much for the great presentation. I remember at Hexacon, you mentioned there was like a Rust IPC implemented, which was which a lot of services on the Lexmark were communicating through. And then you mentioned that basically the good point of it was the lack of memory corruption issues that could have happened. But again, there was a lot of other stuff being called by the IPC server. Was the IPC server reachable from the outside, or was it just local to the services?
It wasn't directly reachable from the outside. No, it was only once you'd got either code execution in a network service or you were on the device itself. So typically it would be used for, I guess, privilege escalation rather than, yeah, they'd made sure that they firewalled it from an external perspective. Yeah.
Thank you. And one last thing, the SNMP command injection that you guys discovered, which you used it for backdooring the Lexmark during the reboot and having it persistent. Lexmark said they have patched it. Did they patch the input through the SNMP command injection, or they patched the whole backdooring the SNMP config?
I actually don't know. I'm not sure. I don't think I've reversed the patch for that. I think I just trusted their work on the patch. Yeah, I haven't looked. I think, yeah, I haven't tried to bypass the patch either. So yeah, I don't know.
Sorry. Thank you very much for the great presentation and your time. Good luck.
Thank you.
Okay, so any more questions? So I think there's a question in the chat that why did you have to chain both exploits? Wasn't enough to get remote code execution independently? So
for the Soho category, you have to compromise the device first through the WAN interface. You have to compromise a router first through the WAN interface, and then compromise another thing which is connected to the LAN. So that's why we chained together it for Soho, basically. Yeah. So you can't just jump into like the second part of the chain. You have, like, the idea of the Soho category was to pivot through the initial stage, essentially. Yeah. Cool. Well, thanks a lot. Thanks for coming on, everyone. Appreciate it.
Yeah, thanks everyone for coming, and a special thanks to Alex for this great presentation, as well as his team NCC Group for supporting this. We appreciate all of you for participating. We hope that we can continue this